Good afternoon, sixth graders. It's Mrs. Hebert. Go ahead and turn in your math journals to your table of contents or in your math notebook and add lesson 10.3, equivalent expressions, and I believe it's pages 55 and 56. Okay, for the lesson today, we are going to actually be using most of the 2 pages of the math notebook. We usually only use one side, but there is a lot of writing for this lesson, and so we need to use almost both sides. So on the first side, on the left side, go ahead and title it 10.3 Equivalent Expressions, and then you're going to divide the page into 3 wide sections, the middle section being probably the biggest, but the first one also being pretty big, and then the last section can be the smallest of them. On the right hand side, you're going to put boxes 4 and 5, and they're both going to be pretty big, especially box 4, and they're going to go all the way across the page as well. And then at the very bottom, you'll have a little room to do some class notes where we'll just do a couple of more examples. Okay, in box number 1, you need to put a number 1 and then right at the top, properties of operations. So in the textbook, it lists all the different properties of operations, and you can refer to those if you would like, but we're going to abbreviate them. They're on page 279 in the math book, but we're just going to abbreviate them and show you what they mean numerically. So the first one is the commutative property of addition. And what that says is that when you add, changing the order of the numbers doesn't change the sum. So 3 plus 4 would give you the same answer as 4 plus 3. For the commutative property of multiplication, it says that when you multiply, changing the order of the numbers doesn't change the product. So 2 times 4 equals 4 times 2. The associative property of addition says that when you add more than 2 numbers, the grouping of the numbers won't change the sum. So I can put parentheses around 3 plus 4 in the problem 3 plus 4 plus 5, or I can put the parentheses around 4 plus 5 in 3 plus 4 plus 5. And it won't change the answer because I'm still adding, I'm doing all addition and I'm adding the same numbers. In the associative property of multiplication, when you multiply more than 2 numbers, the grouping of the numbers won't change the product. So 2 times 4 times 3, and if you put the parentheses around 2 times 4 and multiply that first, it will give you the same answer as if you multiplied 2 times 4 times 3 and multiplied the 4 and the 3 first, because you're using all multiplication, and so the order that you do them in isn't going to affect the answer. Then the distributive property basically says that when you multiply a number by a sum or difference is the same as multiplying by each number in the sum or difference and then adding or subtracting. Now that sounds complicated, but if you look at the examples, it's really not that complicated. So you can have 6 times 2 plus 4. What that means is you can take the 6 times the 2, and I'm going to write it down here at the bottom. You don't have to write this part. You can write it up at the top, but just so you can see it better. So if I have 6 times 2 plus 4, I can take the 6 and multiply it by the 2 first. So 6 times 2. Then I can add. And then I can add 6 plus 4. 6 times 4. 6 times 4. So that's basically what the distributive property is saying. You can distribute those numbers out, take them out of the parentheses, and multiply them by the 6, by the number you're multiplying by. So 6 times 2 plus 4 would give you the same answer as 6 times 2 plus 6 times 4. And you can test that out because you can say 6 times 2 plus 4 equals 6 times 6, which gives you 36. And then 6 times 2 plus 6 times 4 gives you 12 plus 24, which will also give you 36. And these are equal. The same thing applies if you are subtracting. So you can have 8 times 5 minus 3 in parentheses, and that will be the same thing as if you distribute your problem separately and say 8 times 5 minus 8 times 3. Then in the identity property of addition, you have basically it says adding 0 to a number won't change the value. So 9 plus 0 equals 9. Anytime you add 0, you're going to end up with the same number you started with. And then similar to that, in the identity property of multiplication, when you multiply a number by 1, it won't change the number's value. And so 1 times 7 equals 7. So go ahead and write those down in box number 1. Okay, in box number 2, and I know this is a lot of writing, but just bear with me. In box number 2, we are going to talk about parts of an algebraic expression. And there are 3 parts to an algebraic expression, basically. Or, 3 parts. The first part are the terms, and the terms are the parts of the expression that are separated by addition or subtraction signs. So we're going to use the same expression in all 3 definitions, and I'm going to show you the difference. So terms are the parts of the expression that are separated by a plus or minus sign. So in this case, the 12 and the 3y squared are separated by an addition sign, so they are terms. Then the 4x is separated by an addition sign, so it is a term. The 2y squared is separated by an addition sign, so it is a term. And the 4 is separated by an addition sign. So in this case, you have 5 terms in your expression. Next are coefficients. Coefficients are numbers that are multiplied by at least one variable. So if we look at that same expression, I'm looking for numbers that are multiplied by at least one variable, so at least one letter in there. And so my coefficients in this particular problem are going to be the 3, because it's multiplied by y squared, the 4, because it's multiplied by x, and the 2, because it's multiplied by y squared. Now, coefficients will not be 12 or 4 because they are not being multiplied by a variable. So in this case, we have 3 coefficients. And then like terms are terms with the same variables, so the same letter, raised to the same power. And that's important to remember, that they have to not only have the same variable, but they have to be raised to the same power. So in this same example, 3y squared and 2y squared both have the same variable, which is y, and the y is raised to the same power of 2. And so I have 2 like terms in this expression. Okay, in box number 3, we're going to talk about combining like terms so we can simplify expressions, make them easier to work with. And so I want you to go ahead and write these 5 examples down. Example A is 3x plus 2x plus 4. And then I'll let you go ahead and write them down. You can see them so I don't have to read them all. But you have 5 examples. And so just pause the video, write those down. Okay, let's go ahead and look and see what we can combine. Remember that like terms have to have the same variable raised to the same power. So in example A, 3x and 2x have the same variable. They both have x, and it's the same power because it's just really the power of 1. And so I can combine those two, and 3x plus 2x gives me 5x. And then I can't combine anything with 4 because I have no more numbers, so it's just going to be 5x plus 4. And that's as simplified as I can get without more information. So that becomes 5x plus 4. Okay, in the second example, 6x squared minus 4x squared minus 3. The 6x squared and the 4x squared have the same variable to the same power, so I can combine them. So 6, you think of them like as a group. 6x squared minus 4x squared gives me 2x squared. And then I'm going to subtract 3 because there's nothing else to combine with the 3. So this becomes 2x minus 3. In example C, you have 3a plus 2b plus 5a, and I'm going to basically simplify that. But before I simplify it, I'm going to go ahead and use the distributive property to create something a little bit easier. So it's going to become 3a plus 2b. Oops, sorry. Let me see if I can erase that. Yeah, okay. 3a plus 2 times b, which is 2b, plus 2 times 5a, which gives me 10a. I know that might be a little confusing. And I don't like that in that color, so I'm going to erase it all and write it in a different color. I'll try writing this in red. So 3a plus 2b plus 10a. Now that I've written it out, I can tell my like terms. I have 3a plus 10a, which becomes 13a. And then there's nothing to combine the 2b with, so that just becomes 13a plus 2b. Okay, next in example D, I have y plus 11x plus 7y minus 7x. So I'm going to combine my y's. I have y and then plus 7y because the plus comes before the 7y. So this, think of y as 1 times y or 1y. And then I have 1y plus 7y. That gives me 8y. And then I can combine my 11x with my, I can subtract 7x because it's minus 7x. So 11x minus 7x, and that's going to give, it's y, it's going to be plus, because of this plus right here. So I combine my y's, so it'll be plus 11x minus 7x, which, sorry, give that up. No, that's right. Plus 11x minus 7x, and then I can combine these, and that becomes 4x. And you could do that in your head, but it becomes 8y plus 4x. And that's as far as I can go, so my expression is simplified. In the last example, I'm going to look and I'm going to say, okay, there is nothing I can combine 2x with because I don't have another x. I only have x squared. So I can't combine that. I can't combine 3x squared with anything because I don't have an x squared anywhere else. And so the only things that I can combine or simplify are 3y plus 2y, which becomes 5y. So this becomes 2x plus 3x squared plus 5y. And that's my answer. Okay, in box number 4, we're going to use the properties of operations to determine if expressions are equivalent. So this is one way that you can tell if two expressions are equivalent. So if you look at example A, it's 3 times x minus 2. And what we want to know is does it equal 3x minus 6? So we're going to use the distributive property, and we are going to combine 3 times x, which is 3x, minus 3 times 2, which is 6. So I used the distributive property. Okay, I put dp for distributive property. And does that equal 3x minus 6? Yes, it does, because 3x minus 6 equals 3x minus 6. So those are equal. Okay, in example B, I have 2 plus x, and we want to know if that's equivalent to 1/2 times 4 plus x. So we'll go ahead and leave 2 plus x, and we'll use the distributive property to help us. 1/2 times 4 is 2, plus 1/2 times x. And so does 2 plus x equal 2 plus 1/2 x? No, those are not equal. So those are not equal. And again, we use the distributive property. In example C, we have 6x plus 8, and we want to know if it's equal to 2 times 3x plus 5. So again, let's use the distributive property to work out the problem on the right. So we'll leave the one on the left as 6x plus 8. And then we're going to say 2 times 3x gives us 6x. And 2 times negative 5 gives you negative 10. So 6x minus 10. So we want to know, is 6x plus 8 equal to 6x minus 10? And no, those two are not equal because you have an 8 here and a negative 10 there, or a minus 10. So that is not equal. Okay, one more. 2 minus 2 plus 5x. We want to know if it means the same thing or if it's equivalent to 5x. And you may just know this just by looking at it, but we're going to use the identity property of addition, which says that anything added to 0 remains the same. So 2 minus 2 is 0 plus 5x. And the identity property of addition says that anytime you add 0 to something, that something will stay the same. So that stays as 5x. So this becomes 5x, and 5x does equal 5x. So it is equal. Okay, in box number 5, we're going to talk about using substitution to determine if expressions are equivalent. So another way you can decide if two expressions are equivalent is by substituting the same number for the same variable. And so if I have 5x plus 65, and I want to know if it is equal to 5 times 13 plus x, I'm going to substitute a number for x in both problems. It doesn't matter what number I use as long as I use the same number for the same variable in both problems. So in this case, I'm going to take, I'm going to substitute 2 for x. So this becomes 5 times 2 plus 65 on the left. I do the multiplication first, so that becomes 10 plus 65, and that gives me 75 on the left. Now on the right, I'm going to substitute the same number. So 5 times 13 plus 2. Then I'm going to do the parentheses first, so it becomes 5 times 15, and 5 times 15 gives me 75, and those two are in fact equal. So I know those expressions are equivalent. Okay, I know that was a lot, but you're basically done with the lesson. These are just what your pages are going to look like, or similar to these anyway. And so you can look at them and see, so this is the left page, and this is the right page. And then that blank spot at the bottom we can use for a little bit of class notes. And that's it, you're done. Well done.